Hey guys, welcome to Pre-Calc Lesson 7.3, Geometric Series and Sigma Notation. We're going to start with a warm-up today and a little bit of review, just letting you guys know where you should be at this point in the unit. So first example, given the sequence 18, 24, 30, 36, find the sum of the first 200 terms. So S200 is 200 divided by 2 times the first term plus the last term, a sub n, or in this case, a sub 100, but I don't know it. So we need to go through and figure out what this pattern is. I'm adding 6 each time. So a sub 1 is 18. The common difference is 6. To find a sub 200, I need to take 18 plus 6 times 199. And we'll just throw that into the calculator. Let me take a look. That is 1,212. So now I can just take that and throw it in there. So that'll be 1,212. And then I'll know the sum of the first 200 terms. I got 123,000. Okay, so that one's pretty straightforward. Next one's actually a little bit more challenging. Given a sub 1 is 22, a sub k plus 1 equals a sub k minus 5. Find S100. So find the sum of the first 100 terms. It'll be 100 divided by 2 times a sub 1, which is 22, plus, I don't know, a sub 100. Now, the way they give you this particular sequence is recursive. So I'm going to take some time here to expand it. I know a sub 1 is 22. A sub 2, well, I don't know what that is. How do you figure it out? What this is saying is to get to the next term, you take the previous term minus 5. Remember, that just represents the previous term. So to get a sub 2, it's simply 22 minus 5. Okay, well, what's that? 17. To get a sub 3, it's 17 minus 5, so that's 12. Well, what's going on here? We're subtracting 5 each time. So a sub 1 is 22, but d is negative 5. So to find a sub 100, which is what I need over here, I need to take 22 minus 5 times 99. So a sub 100 in this case, let me take a look, is negative 473, and that's what I need to plug into my sum formula. So let me actually do this. It's going to be a minus, not adding, minus 473. And if we throw all that into the calculator, I got negative 22,550, if I did that right. All right, another quick review here. Finding D or R when given non-consecutive terms. Another formula we have to have memorized for this unit. To find D is a sub n minus a sub m over n minus m. And again, I don't really care if you have this formula memorized. Just know how to find D. So here's an example. Arithmetic sequence, a sub 1 is 52, a sub 4 is 67. It tells me it's arithmetic, so I know I'm adding the same number every time. To get to that, find D. Well, to find D, I'm simply going to take 67 minus 52 and divide that by 4 minus 1. All right, you can throw all that into the calculator, but I can do that relatively quickly. That's 15, that's 3, so D is 5. A sub n is simply your a sub n rule, a sub 1 plus d times n minus 1, except you put in a number here and you put in a number there. Okay, so a sub 1, they gave us 52 plus d, which is 5, times n minus 1. And I would just leave it like this. You can clean that up a little bit, distribute the 5, but it's not necessary. Expanded notation. So expanded notation, and at this point you can probably do this in your head, but you have to list out the first 5 or 6 terms. So if I know I'm starting with 52 and I'm increasing by 5 each time, we don't really need to write all those operations out. You know it's going to be 52, and then 52 plus 5 is 57, and then 57 plus 5 is 62, 62 plus 5 is 67, 67 plus 5 is 72, and that's good enough. They'll just keep going. Now I need to find S sub 50. Well, that will be 50 divided by 2 times a sub 1, which is 52, plus a sub 50. So I need to do a little work to get a sub 50. I'll do that down here on the side. A sub 50 equals A sub 1, which we said was 52, plus D, which we said was 5, times 49. And let me see what I get for that, 297, which I just need to plug in right there. And throw that into the calculator, I got 8,725. Okay, let's practice finding R. So this would obviously be for a geometric series. The formula is n minus m root of a sub n divided by a sub m. And again, I don't care if you have this formula memorized or if you just know what to do with the numbers, that's totally fine. So here we go. Geometric sequence, a sub 1 is 6, a sub 4 is 48. I need to find R. Okay, well that's going to be 4 minus 1 root of 48 divided by 6. If this was calculator inactive, I think we could do this because 4 minus 1 is 3. So I'm taking the cube root of 48 minus 6, which is 8. And we should all know the cube root of 8 is 2. Find my a sub n rule, which is a sub 1 times r to the n minus 1. And you replace this with a number and replace that with a number. Okay, so a sub 1 was given to us. That's 6 times r, which we calculated as 2, to the n minus 1. Expanded notation. So again, I don't think we have to write out a sub 1, a sub 2, and so on and so forth. We know we're starting with 6, and we're doubling every time because that's our R value. So I can probably just list those out. 6 times 2 is 12. 12 times 2 is 24. 24 times 2 is 48. 48 times 2 is 96, and that's good enough. There's 5 terms. Okay, so now we get to the new part of today's lesson, the formula for a finite geometric series. Unfortunately, I don't have time to derive this formula, so I'm just going to give you the formula here. It's a times 1 minus r to the n over 1 minus r. Now, there's other versions you might see. I'll list them here, but this is the version that I prefer. I think it's the easiest to work with. But you might also see something like this, where they bring the a, that should be a sub 1, sorry, a sub 1. They bring a sub 1 out front, and then in parentheses you have 1 minus r to the n over 1 minus r. It's the same expression. Or sometimes they'll distribute that a sub 1. So you see a sub 1 minus a sub 1 times r to the n over 1 minus r. And that way is really, it's a little bit more cumbersome, obviously. So mainly these two, and I prefer this version. All right, so let's put it into practice. Given 5, 15, 45, 135, dot, dot, dot. Find a sub n and a sub 8. Okay, so to find a sub n, I need a couple things. A sub 1, well, that's 5. I need a value for r. What are we doing each time? Well, we're multiplying by 3. So r is 3. My a sub n rule is a sub 1 times r to the n minus 1. To find a sub 8, you just simply plug an 8 in for n. So that's going to be 5 times 3 to the 7th. All right, that's going to be sort of a large number. Let me throw in my calculator. I got 10,935. Now, find the sum of the first 6 terms. Well, what I don't want to do is find all 6 terms and then add them all up. We've got this cool formula right here for the sum of an n number of terms. And the other great thing about this formula, I don't know if you picked up on this earlier, I need a sub 1 and I need r. What don't we need? We don't need a sub n, so you don't have to find the last term for a geometric series, and I think that's kind of cool. So let's apply it here. Find S6, the sum of the first 6 terms. All right, so a sub 1 is 5, times 1 minus r, which you said was 3, to the n, which is 6, all divided by 1 minus r. Now, I highly recommend that you take this whole UNLV calculator active, you take all of this and put it into your calculator, create a fraction using your function key, and spare yourself the simple mistakes of maybe, dividing by 1 and then subtracting a 3, messing up the order of operations. Just throw that all in your calculator in one shot, and I got 1,820, as should have you. Okay, let's try one more like this. Given 80, 40, 20, ... find a sub n and a sub 10, and then the sum of the first 7 terms. Okay, so what do we know? A sub 1 is 80. R, remember, an easy way to find R, if you're looking here like, oh, the numbers are decreasing, it's not as easy, is to always take a sub 2 and divide it by a sub 1. All right, so that kind of reminds you, oh, it's less than 1 because the numbers are decreasing. So R is going to be 1/2 in this case. So my a sub n rule will be a sub 1, 80, times R, which is 1/2, to the n minus 1. To find a sub 10, you simply plug in a 10 for n. So it's 80 times 1/2 to the 9th power. Now for this one, I got, well, you can get a decimal here. I prefer to math frac it. Just remember, fractions are always better than decimals. So if you can express as a fraction, that is preferred. Okay, and lastly here, I want to find the sum of the first 7 terms. So that's going to start with a sub 1, which is 80, times 1 minus r, which is 1/2. Now here's where you have to be careful. You can use a 0.5 if that's easier, but I have to take that to the n power and divide that by 1 minus 1/2, which is ends up being a negative 1/2. So if you throw all that into the calculator, you should end up with 158.75 or 158 3/4. Either way would be fine here. Okay, and the last of the new material for today's lesson, sigma notation. We did a little bit of this in Algebra 2, but we didn't do it justice, unfortunately. So this right here is sigma notation. All right, we need to know what these parts represent, and I'll draw them up here, and then we'll list out the variables here. So this is our starting value, or index, I should say. This right here will be our rule, the rule for each term. So what we're going to do is we're going to take our index, plug it in here, and then whatever this says to do, that's what we're going to do. It could be like 2i, it could be 3i minus 1, it could be I squared, whatever it happens to be. And then here, the end is the end value. All right, so a sub I is our explicit definition or rule. I is the index. N is the max term number, or the last. And 1 is the starting term number. For all of our examples in this unit, that's going to be a 1, but it doesn't have to be. You can start at a 3, you can start at a 7, doesn't matter. Okay, so let's practice a few. I think it might make a little bit more sense after we do this here. So it says write an expanded notation and find the sum. I'm going to do this very slowly for the first few examples. What we've got here is a rule. This is saying 3 times I plus 11. I is going to start at 1. So what I'm going to do first is take a 1 and plug it in here. Then I'm going to take a 2 and plug it in there. And then a 3, and then a 4, and then a 5, and a 6, all the way to 80. Now, obviously, we're not going to write all those out. So here's what I like to do. Like I said, I normally don't write all of this out, but I'm going to say, okay, what happens when n equals 1? How about when n equals 2? How about when n equals 3? And then ... How about when n equals 80? So when n equals 1, I take a 1 and I put it in here. So that's 3 times 1 plus 11. That's 3 plus 11, that's 14. Plus, that's what this represents. It's a sigma. You don't put commas between these. It's addition. Now what I'm going to do is I'm going to take a 2 and plug it in here. So 3 times 2 plus 11. That's going to be 17. So here I have 17. Plus, now I take a 3. Put a 3 in here. 3 times 3 is 9 plus 11. That's going to be 20. Plus, ... plus, now I'm going to take my 80. 3 times 80 plus 11. 240, I think that's 251. Okay, so there is expanded notation. The first three and the last. Now, how do I find the sum? Do I want to list out 80 numbers and throw them in the calculator? No. So what we're going to do next is determine the pattern. What are we doing each time? So if we take a look at that, 14 to 17, I went up 3. 17 to 20, I went up 3. So this is arithmetic. And I have a sum formula for arithmetic. S of 80, because there's 80 terms, equals 80 over 2 times the first term plus the last term. So we're applying our summation to our sum formula for an arithmetic series. And then you just have to put that into the calculator. Let's see what I get there. I got 10,600. Okay, let's try another one. So again, I'm not going to write out this time n equals 1, n equals 2, n equals 3, n equals 80. But basically, I want to do the first three and the last, starting with 1. So I'll do 6 times 1. Okay, what I get there, that's 6. Plus, then I do 6 times 2. Okay, that's 12. Plus, then I do 6 times 3. That's 18. Plus, dot, dot, dot. Plus, now I do the last one, which is 8. 6 times 8, 48. So there's expanded notation. Now I need to find the sum. Well, notice here, I'm just adding 6 each time. So if I want the sum of the first 8 terms, that tells you how many there are. That'll be 8 divided by 2 times the first plus the last. That's much faster than throwing, adding up all those numbers by hand in a calculator. And I got 216. Okay, so now what we're going to do is we are going to write something in sigma notation. All right, so it says write the sum of the first 20 terms of the series in sigma notation. Well, first thing I need to do is determine what type of series we have. So what are we doing here? Looks like I'm adding 8, adding 8. So I know a sub 1 is 1. I know d is 8. So sum of the first 20 terms. I need sigma notation. I like to use n's. You can use I. Some people use k's. So I'm just going to say n equals 1. I need 20 terms, so that's going to be 20 there. So the question is, what is my rule? How do you get the rule? Well, here's how you get the rule. You recognize that this is arithmetic. And basically, you just need to come up with your a sub n rule for arithmetic, and that's going to go here. Okay, so let's see. A sub 1 is 1. D is 8. That's n minus 1. On the first day, I talked about how you can leave it like this, or you can distribute and then clean this up. In this case right here, when I need to plug this back into a summation, I want to clean this up. All right, so this will be 1 plus 8n minus 8, or 8n minus 7. So I cleaned that up, and that will be my rule in this summation. It's probably good practice to use parentheses here. All right, that's sigma notation. Now it says find the sum. Well, I'm not using the sigma notation to find the sum. I'm going to use this information over here. I've got a formula for the sum of an arithmetic series. There's 20 terms. So I know that's going to be 20 divided by 2 times a sub 1, which is 1, plus a sub 20, which I don't have a sub 20. So I can use this to get a sub 20 really quick. A sub 20 will be 8 times 20 minus 7. 160 minus 7 is 153. That will go right here. And then we just throw that into the calculator, and I got 1,540. Okay, example 8. Write the sum of the first 10 terms of this series in sigma notation. So I can start this. I know sigma notation. It's that uppercase sigma. N equals 1. It says 10 terms, and there's 10. Hard part is this. How do you get that? Well, you have to take this sequence here and come up with an a sub n rule for it. Let's determine what we have. 1 goes to 3 halves. 3 halves goes to 9 fourths. 9 fourths goes to 27 eighths. I'm clearly not adding the same number each time. I'm actually multiplying by 3 halves. This is kind of a giveaway, going from 1 to anything. If it's geometric, that is the value of r. So each one of these I'm multiplying by 3 halves. So what do we know? A sub 1 is 1. R is 3 halves. What is my a sub n rule? A sub 1, just 1, times r, 3 halves, to the n minus 1. So this will go here. You don't really need to put that 1, so it's simply going to be 3 halves to the n minus 1. There's your sigma notation. Find the sum. Well, now I have to apply the sum of a geometric series, which is a sub 1. That's just 1 times 1 minus r. So again, it's a fraction. You can use a 1.5 if it helps, but I have to take that to the r. So that's 10th over 1 minus r. So be careful the way you enter this into your calculator. Use your parentheses here, or like I said, you can make that a 1.5 if that's easier. But remember, this needs to be calculated first. Then you take 1 minus that value, divide it by, and this obviously gives you a negative 1/2 on the bottom. But anyway, throw it into your calculator. I got 113.33, and that would be what we call an approximate value. If the question says exact, that means it needs to be a fraction. So exact value would actually be this crazy fraction. You could say 113 and 1/3, or 58,025 over 512. So know the difference between approximate, which is always a decimal, and exact, which is a fraction. Okay, one more, last example here. Write the series 1, 5, 9, 13 plus 217 in sigma notation. Find the sum. Wow, all right, well, what are we doing? 1 goes to 5, 5 goes to 9, so I'm adding 4 each time. So what do we know? We know a sub 1 is 1. We know d is 4. Okay, so a sub n is a sub 1, which is 1, plus d, which is 4, times n minus 1. Okay, let's clean this up a little bit. That's going to be 1 plus 4n minus 4. So a sub n equals 4n minus 3. What's the hard part here? N equals 1. This is 4n minus 3. What don't we know? I don't know how many numbers are in here. So remember how we did this. I think we did it in the last lesson. This right here is your a sub n. So if I take 217 and plug it in right here for this, and then solve for n, that tells me how many numbers are in here. Okay, well, I'll do that over on the side. So I get 217 equals 4n minus 3. Add 3, you get 220 equals 4n. Divide by 4, n is 55. That would go right here. So that tells me there are 55 numbers in this particular series. Find the sum. So again, for my sum, if there are 55 numbers, I want the sum of the first 55. That'll be 55 over 2 times a sub 1, which is 1, plus a sub 55, which is my last number right there. You don't have to do anything to calculate it. It's given to you. Then you just throw that in the calculator. And I got 5,995. Whew, that was a long day of notes. Thanks for hanging in there, guys. I appreciate it. As usual, if you have any questions, don't hesitate to reach out, and we'll see you in class soon.